Right now, we are going to see about the objectives of the MIMO technology and the objectives of that multiple input, multiple output system. It gives the history. What we are going to see is a history of MIMO technology, and we are going to understand the concepts and as well as the keywords. We are going to see what is MIMO and different techniques that has been used in MIMO technology. An important concept of MIMO is that MIMO OFDM, orthogonal frequency division multiplexing. Okay, and at last we are going to see the applications of MIMO technology. The next what we are going to see is wireless LAN, how we are going to explore that wireless LAN. It has been explored in office, home, and as well as in hotspot area. Wireless LAN technology advances with the rapid advancement in standards and as well as in data rates, the range, and as well as the coverage. This growth has been continuous. The keywords that has been used in MIMO technology will be the multipath, or we may say it as relay fading, antenna gain, diversity gain, SNR, that is signal to noise ratio, and co-channel and as well as adjacent channel interference. We are going to see delay spread. We've seen the keywords that has been used in MIMO technology, which uses the space-time coding and as well as spatial multiplexing, which uses smart antennas. And it has the wireless channel has some of the limitations, in which the first we'll discuss about fading. The fading, as long as the signal is getting transmitted from the transmitting end and to the receiving end, the quality of the signal is getting reduced, or we may say it as the signal has been attenuated. Hence, it comes under fading. And the types of fading we seen it as a relay fading. The next one will be ISI. ISI, an important concept that is intersymbol interference, in which more number of signals is getting transmitted. It tends to create overlapping of the signals. Hence, that overlapping of those signals allows us to get that intersymbol interference, in which it also reduces the quality of our transmitted signal. Along with that, there will be co-channel interference. Also, there will be the adjacent channel interference, which we said as CCI and as well as ACI. The next will be the noise, that is the unwanted signal that will be added along with the transmitted signal, what the signal we are going to send from the transmitting end and to the receiving end. The last one will be the Doppler effect, in the sense in which the transmitted signal is getting abstracted, or the quality of the signal is getting reduced. Those things will be happened by tallest buildings and as well as the moving vehicles, example cars. So what it does, it makes the signal to be spreaded, and it tends to create a delay spread in that receiving antenna. So these are the hurdles in which the wireless signals faces. And next we will see the wireless fundamentals, in which the wireless fundamentals, what it says, as long as the signal is getting transmitted from one end to another end, surely there will be a drop in that quality of the transmitted signal. So those comes under the wireless fundamental channels. Then we are going to see about the conventional SISO wireless systems, single input, single output, which is one of the special cases of MIMO systems. The next one will be multiple input, multiple output wireless systems. In that single input, single output system, single input, a single output system, there will be the wastage of energy, and it consumes more amount of energy. Those will be overcome by the use of MIMO wireless systems, and in which the transmit power can be minimized. And we are going to see comparison between the multipath with the capacity. When there will be a multipath signal, surely there will be the capacity has been improved. Fundamental steps will be mentioned in. And the next, we're going to see about the pre-coding. It is another type of interference developed due to the use of multiple antennas, which is called as multi-stream interference (MSI). And this multi-stream interference is created by the use of multiple antennas, and this one will be the interference. And to remove this ISI, we use pre-coding at the transmitter and as well as the receiver to avoid or to reduce the multi-stream interference. The output of the space-time encoder is weighted by a pre-coding matrix before the transmitter, and it uses a pre-coding algorithm. For example, we may say it as Tomlinson-Harshima pre-coding. Next, we will see about the channel capacity. The channel capacity has been measured by for both SISO and as well as for MIMO. For SISO, the channel capacity C will be equal to B log 2 of 1 plus X, and for MIMO, it will be the channel capacity will be summation B log base 2 1 plus X by N multiplied by Y, where X is the signal to noise ratio and Y is the singular values of radio channel matrix, and where capital N is the number of transmitter and receiver antenna. And in the next, we are going to see about the diversity. In MIMO, the same information can be transmitted from multiple antennas simultaneously. The probability that the information is detected accurately will be increased, and to carry over the diversity, we will be having different types of diversity, that is spatial diversity, temporal diversity, and as well as frequency diversity. To implement a spatial diversity, we're going to see spatial multiplexing, that is the implementation of spatial multiplexing. It can be implemented by using a vertical or horizontal encoding. And these things are carried out by VBLAST, which is said to be as Vertical Bell Labs layered space-time architecture. And next, we're going to see about the space-time coding in MIMO. This space-time coding is employed to improve the reliability of the data transmitted, and we'll use the multiple transmitting antennas to carry out this MIMO process. And to carry out this STC, that is space-time coding, it uses a trellis code which distributes a code over multiple antennas and multiple time slots, which provides the coding gain and as well as the diversity gain. Thank you.